This is the second part to the distance time graphs. Here we go. So you'll find in your book where you don't have a straight line for a distance time graph. Gosh, time is just missing at the bottom there. You can see it. Anyway, so if you've got distance time graph here, you can find, well, you can see the fact the steepness increases, therefore this object is accelerating because the gradient or the steepness of the line is increasing. Now what they can ask you is to work out the speed at a certain time. Now I reckon they've got it about here. Ooh, it's about there. They're saying about 6.5 seconds is they want you to work out the speed. So what you do is you draw something called a tangent to line. Now if you've not met this in maths yet, you will see it. And what you do is you put it along here and you're getting the steepness just at that 6.5 seconds. Then what you do is you then make your triangle like this. Now I'm going to start using different symbols now to help you, but what you can see here is you then work out the speed from this triangle. So what we use symbol is a delta D, which is going to be a change in distance, and here's going to be your change in time. Now that's a delta symbol. So therefore you know your speed is going to be the change in distance, which is the delta t, over a change in time, which is delta t. Therefore your delta d, well, I'm going to say here, I'm going to make it nice and easy, is about 140. Then I'm going to take this one down here. Okay, I'm going to make it nice and easy. I'm going to say that's 20. Probably a little bit different, but make it easier for myself. Then I'm going to take that is 9, and that is going to be 4. And then we'll do 140 minus 20, then that's obviously going to be 120. 9 minus 4 is going to be 5. And then what you do then is you bung that in your good old calculator. You take your 120, you divide it by your 5, and we work out then, we all know that is equal to, it's going to be 24 meters per second. Okay, so that's how you work it out. So I'll repeat that one there. What you do is you look at your triangle, you take your 140 minus your 20, you get your 120, and then you take your 9 minus 4. What you do then is you work out your speed from there. Now, what I'm going to include in this post is these graphs here. And it asks you to work out the speed at different times in all these 5 graphs. Okay, and how you do it is this. So on this one, I can't remember where it is. It says calculate the speed after 60 seconds, which is up here. Now I'll show you how you do it. And going back to where I was. So you take your 60 seconds and you go up here and you do that like that. Now I'm going to have a go at doing this. How well I can do it without using a board, I don't know, but we'll have a go. Then you draw your line. I'm going to roughly say my line going to be like this. Now I'm going to have a go of putting a tangent. I'm going to make it roughly about here, going there. And what I'm going to do is I'm going to extend all the way down to 0, try and get the straightness of the line there. Now, in some cases you can take it down to 0, it makes it a bit easier. Now, to work out now my speed, I dot that down like this. Okay, and what I can see here is that again my speed is going to be my change in distance divided by my change in time. So my change in distance, I'm going to take it from 20, and I've taken it down to 0 to make it nice and easy because it's going to be 20 minus 0. Therefore my change in time roughly is going to be, well, my 70 is going to be here. I think that's about 78. And going down to here, well, here's going to be 30. I'm going to take that roughly to be 28. Okay, then you're going to give it 20 over top. You then take away 20 divided by your 50, which is then going to be obviously equal to my 2/5. And then that's going to be here. Take the two together, and that's going to pop down then to 0.4 meters per second. And that's your answer going from there. So what it allows you to do, it allows you to, well, you work out then at that point. Now, you're not going to get different values. It depends how you draw your tangent. And in the examination situation, they will be a little bit flexible with that and to give you a range of values you must be popping into. Now, as I said before, is what I'd like to do is I'd like you to do, well, where it says on the sheet here, is to work out the speeds at different times with them. And the interesting one comes up here is calculate the speed after 11 seconds. Now, in your 11 seconds, it pops out about here. Now, it doesn't matter if you draw the triangle on top and bottom, but I would draw my triangle at the bottom here with that one. And going back to here, so I can draw it on, is what I would do is basically go down to your 11 seconds about here. You're trying to draw a triangle about there, make it reasonably big again to work out. You can, if you want to, take it right down to here. So you take down to 0 distance, which makes it slightly easier. Anyway, like you do, have a go at that and calculate the speeds according to the worksheet. Okay.